All right, so we're moving on. This is going to be 7.3. Looks like that. Okay, we're going to look again at exponents. This whole chapter is exponents, but zero and negative exponents, and then also fractional exponents as well. Yes, I know. Everyone likes fractions. Let's start with 0 and negative. What is 2 to the power of 0? Or what's 2 to the power of negative 1? Or even 2 to the power of negative 2? Like, what do these equal? Or do they equal anything? Well, let's analyze this a little bit. Let's start with 2 to the power of 4. If I were to evaluate that, how would I figure it out? Well, I'll just take 2 and multiply it by itself 4 times. So it's 2 times 2 times 2 times 2. So that's 4, 8, 16. 16. Okay, what if I were to go down one and do 2 to the power of 3? What's that? Well, it's just 2 times 2 times 2, which is 8. And technically, when I went from here to here, I subtracted 1 from the exponent, and then over here, what happened? Well, there was just 1 extra 2 here, so to get rid of it, I just divided by 2. Right, 16 divided by 2 is 8. And we can follow this pattern. Right? 2 squared is just 2 times 2. Right? We got rid of one of those 2. So it's 4. Or you can just take 8 and divide by 2. Okay? And what do? We just subtracted 1 from the exponent. 4, 3, 2. Now, 2 to the power of 1 is just 2, which equals, well, 2. Right? And how did we get that? Well, you can just take 4 and divide it by 2. You can see where I'm going. Now we have, well, if I subtract 1 more time, I get 2 to the power of 0. Oh, what do I write there? Here it's like 2 times 2 times 2, 2 times 2, 2, and then what? Well, why don't we follow this pattern? Here we did 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Well, what's 2 divided by 2? Or what's any number divided by itself? It's just 1. And it turns out that works with anything. Right? 3 to the power of 0 is 1. 8 to the power of 0 is 1. 8,567,202 to the power of 0 is 1. And you can even say that x to the power of 0 is 1, even if you don't know what x is, because you know that anything to the power of 0 will be 1. Well, let's continue this pattern then. If I subtract 1 again, I get 2 to the negative 1. What's that equal? Well, take 1, continue this pattern, and divide by 2. What's 1 divided by 2? And you can say a half or 0.5, but I'm not going to do decimals. Let's just write it as a half. Okay, and if you continue, 2 to the minus 2, what's 1/2 divided by 2? Well, it's a quarter. Or 2 to the minus 3, that's an 8. Do you see a pattern here? 2 to the minus 1 is actually 1 over 2 to the power of 1. 2 to the minus 2 is actually 1 over 4, but we can say 4 is just 2 to the power of 2. 2 to the minus 3 is 1 over 8, but we can just say 8 is 2 to the power of 3. So whenever you have a negative, right, you're just taking the reciprocal, you're flipping the fraction. Okay, and that's what a negative exponent is. So let's try a couple examples on the back here to see if we can do this. And then I'll let you do the rest and I'll post my answers later after you've tried it. All right. Let's do example 3a on the front of 7.3. So here we have 5 to the 3 times 5 to the 4 over 5 to the 7. Okay, let's look at the numerator. you're multiplying common bases, you add the exponents. 4 plus 3 is what? 7. Okay, so we have 5 to the 7 divided by 5 to the 7. All right, now when you're dividing, you subtract the exponent. So 7 minus 7 is 0. And 5 to the 0 is 1. Okay, let's try another one. Let's try one that's a negative. All right, we'll do b. So 3b. So here you have 3 to the power of 3 times by 3 to the negative 2 over 3 to the 4. Okay, on the numerator, we are multiplying similar bases, so we add the exponents. But what's 3 plus negative 2? Okay, 3 plus negative 2. Negative and a positive give you a negative, so what's 3 minus 2? It's just 1. So we're going to have 3 to the 1 over 3 to the 4. Now when I do that, we now have to subtract because we're dividing similar bases. So 1 minus 4, what's 1 minus 4? It's minus 3. So here I get 3 to the minus 3. Now if I were to write this as a positive exponent, and I can easily say in the question, write your answer as a positive exponent, well, we're going to write this now as 1 over 3 to the power of 3, like that. And if I said evaluate, well then you have to do 3 times 3 is 9, okay? 9 times 3 is 27, and you would write it as 1 over 27, right, as a fraction, okay, as opposed to just punching it in your calculator and giving me a huge decimal. Okay? Leave it as a fraction. All right, next, if we go on the back, question 1 is similar to these example problems I'm doing, but let's go over question 2, an example from it anyways. Question 2 says evaluate without using a calculator. Oh, and then we have fractional exponents. So I want to look at those fractional exponents. So let's look at part B. Part B says 125 over 8 to the power of 1/3. What's a fractional exponent? Well, think of it this way. 4 to the half is the same as the square root of 4. 8 to a third is the same as the cubic root of 8. And so on, right? 64 to the quarter is the same as the, I don't know what you would call that, but the 4th root of 8. Okay, and so on and so on. So, in this case, we have 125 over 8. Now that 1/3 needs to apply to everything in the bracket. So I can rewrite this as the cubic root of 125 divided by the cubic root of 8. Now the cubic root of 125 is just 5, and the cubic root of 8 is 2. Okay, so now we have 5 over 2, or 2.5, 2.5. Okay, I know that's harder to do without a calculator, but it might be a little easier if you can think of 125 to the power of 1/3 as the cubic root of 125, or what number multiplied by itself 3 times will give you 125. That would be 5. Okay, so that helps you also with questions 3 and 4. Question 3 says write this. Go over this. We have the 4th root of 256 cubed. It says write that in exponential form. Well, that's cubed, so we have 256 cubed. If you want, you can put it in brackets. And that 4 is just 1 over 4. And then here we have a power to a power. When we multiply it through, right, 3 times a quarter is just 3/4, like that. Okay, part 4 says write 2/16 to the power of 2/3 in radical form. So radical form looks like this. Right? This is exponential form, and this is radical form. So now we're just going the other way. So you have 2/16 to the power of 2/3. Well, the 2 is just squared, so we can think of this as 2/16 squared, all to the power of 1/3. And that 1/3 is your cubic root. So that's your cubic root of 2/16 squared. Questions doesn't say evaluate or anything, it just wants to make sure you can go back and forth between exponential and radical form. Okay, so try the other questions that I haven't done and check your answers. And we'll move on to 7.4 towards the end of this week, because I don't want to go too fast. Okay, see you later.